Hi everyone, welcome to Mr. Wagid's math class. Today we will try and solve linear equations by graphing when you have two equations equal to each other. So the first step to graph this is to create the two equations. The first equation is negative x plus y, so make it as y equal negative x plus 1. That would be your first equation to graph. And the second equation to graph would be after the equal sign. Make it y equal 2x minus 5. Now they both written in slope-intercept form. We can graph it by starting at negative 5 for the first one, which is the y-intercept. So go to negative 5 on the y-axis and put a dot. Now use the slope, which is 2. This is the slope. To use the slope, it's the rise over run, so make it as a fraction 2 over 1. Now you go up to right 1, up to right 1, up to right 1, up to right 1, to right 1, or go down to left 1, down to left 1. So that is your first equation to graph. I need the second equation to graph. Let me change the color so you guys can see it better. You start at the y-intercept, which is positive 1. So I go on positive 1 on the y-axis. And now use the slope. The slope is negative 1. Make it a fraction. It becomes negative 1 over 1. So you go down 1, right 1. Go down 1, right 1. 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 And now graph it. Watch how the two lines intersected at the point coordinate 2, negative 1. So x has to be 2 to make those two equations equal. Now let's check and see if this solution x equal 2 is the correct solution, which means does it balance the equation. If I substitute x with 2, so negative 2 plus 1, does it equal 2 times 2 minus 5. All I did, substituted x with the solution, which is 2. Now negative 2 plus 1, does it equal 4 minus 5? Negative 2 plus 1 is negative 1. It did equal negative 1. It is balanced. That means my solution is correct. Watch how I only use the value of x from the point of intersection, which is x to y negative 1. I only use the x, not the y, because the y has to be the same for both. And the x is what I need to balance this original equation. Now, what about solving absolute value equations? I wanted to remind you that absolute value has two answers all the time, one positive, one negative. So the first step is to write the two systems, one positive, one negative. Let me show you how. The first one is x plus 1 equals 2x minus 4. And the second one is x plus 1 equal the negative 2x minus 4. So those are the two separate systems that we need to graph to find the solution or the values of x that makes the absolute value true. Let's graph the first one. That's why we have two separate graphs, because we have two separate systems. One, the positive value, and the other one is the negative value. So let's see what that means. First of all, separate the equations. The first equation, write it as y equal x plus 1. To graph it, we always start with the y-intercept. And the y-intercept always is the constant, positive 1. So go out positive 1 on the y-axis. And now use the slope. The slope is the coefficient of x. So there isn't 1. So put a 1, and I need it as a fraction. So it's 1 over 1, which means you go up 1, right 1, up 1, right 1, up 1, right 1. Or you can go left 1, down 1, left 1, down 1, left 1, down 1, left 1, and keep it linear. Now connect it. Now I needed to graph the second equation. Separate it as y equals 2x minus 4. Start with the y-intercept, which is -4. So go on the y-axis, -4, put a dot. And now use the slope, which is 2, but I need it as a fraction, so put it over 1, which means you go up 2, right 1. So go up 2, right 1, 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 up 2, right 1. I don't need to continue because I see where they crossed. So when I connect them, it made a linear equation, but those two lines intersected at x is 5, y is 6. So 5, 6. But I only need the value of x. So the solution for the first system is x equals 5. So that's your first value of x. Now I need the second value of x using the second equation. So let's graph the second equation now. First of all, we need to get rid of the parentheses using distributive property. So put -1 outside the parentheses, and now multiply -1 times 2x, which is -2x, and -1 times -4 is +4. Bring everything else down, x plus 1. Now I need to graph those two equations separately. Let's graph the first one, which is x plus 1. Create the first equation by saying y equals x plus 1. To graph it, it's in slope-intercept form. Start with the y-intercept, which is +1. So go on +1 on the y-axis. Now I need the slope to draw other points. The coefficient of x is 1, so put it over 1, which means you go up 1, right 1. So go up 1, right 1, up 1, right 1, up 1, right 1, up 1, right 1, or go down 1, left 1, and keep it linear. And connect them. And of course it's a line, continue going forever if I need to. Now the second equation, let's graph it. The second equation is -2x plus 4, so write it as y equal -2x plus 4. Start with the y-intercept, which is 4, on the y-axis. So I will start with +4 on the y-axis. And now use the slope, which is the coefficient of x. This time it's -1, so put it over 1, which means you go down 2, right 1. Go down 2, right 1, down 2, right 1, down 2, right 1. I can stop because I can see where those two lines intersected, which is the solution. Where those two lines intersected at 1 for the x and 2 for the y, but I only need the x value because I only have x in the original equation. So the second solution would be x equal 1. So those are my two solutions, x equal 1 and x equal 5. Now I need to check and see if it's correct using the original equation or the absolute value equation. Now that we found the solutions x equal 1 and the other one x equal 5, I need to check and see if those solutions are the right solution by substituting the x back into the original equation. So write the original equation, which is the absolute value of x plus 1 equals 2x minus 4. Substitute x with 1 and see if it works. If x equal 1, that means the absolute value of 1 plus 1, does it equal 2 times 1 minus 4? All I did, substituted x into the equation. 1 plus 1 is 2, so does the absolute value of 2 equals the absolute value of 2 minus 4? 2 minus 4 is -2, but still in the absolute value until the end. And now I evaluate the absolute value. The absolute value of 2 equals 2. That means 2 is only 2 away from the 0. The absolute value of -2 is also 2 because the -2 is also only 2 spaces away from the 0. So it did check, which means my answer or solution x equal 1 is correct solution. Now let's check the second solution, see if it's right. Again, write the original equation, which is x plus 1 equals 2x minus 4. Now I need to substitute x with 5 into the equation. 5 plus 1 does it equal the absolute value of 2 times 5 minus 4? 5 plus 1 is 6. Again, you're checking. So does the absolute value of 6 equal the absolute value of 10 minus 4? Make sure you keep the absolute value till the end. 10 minus 4 is 6. It's still in the absolute value. Does it equal the absolute value of 6? Yes, the absolute value of 6 equals 6 because 6 is only 6 spaces away from the 0. Same thing on the other side. It did check, which means my solutions x equal 1 and x equal 5 are the correct solution. They would balance the original absolute value. That's it for today's lesson. Thank you so much for watching. Have a great day.